optimized Genesis sequence.
Good afternoon, everyone. Thank you for joining my session. It's actually like my session between you and the beers afterwards. So I'm happy that you're joining for Lean Spring Boot applications for the cloud. And I'm going actually to show you how to improve your Spring Boot applications, like with everything I know, what I have learned in the last 2 years while doing benchmarks and other things. So I was on a journey on the topic, and I will show you some numbers, because sometimes you just see some nice graphs or like some best case scenarios, but I will give you some more insights. So the numbers you are going to see, they're kind of for educational purposes only. So that means like do your own benchmark responsibly, right? I mean, your application will behave different than mine. Just keep that in mind. But what I'm going to show you is actually like that you see an indication what you can do and how actually like your Spring Boot application will improve. So that's the goal. Short about me, I'm Patrick, I'm from Switzerland. Actually, like I work with people on solving problems or creating software. So I love to have this interaction with humans, with developers, but also like with business as well. And I do also like other things besides coaching, and I'm also very much involved in the software development community in Switzerland as well. But let's get to the problem. What is actually the challenge? Why does the whole thing actually matters? When moving to the cloud, you will realize that the resources you're going to use are different from the ones you have on your laptop. You probably realize that applications are starting faster on your laptop because you have more cores than when you are moving to a Kubernetes cloud, for example. So actually, like that's why I do this talk, to show you like how you can do this or how you can change it, that actually your application startups faster and so on and so forth. And I'm pretty sure actually like by the end of the talk you have some takeaways with you which you can apply like on Monday immediately in your project, because it will be that simple. And I'm not like diving too much into details, but I will show you some tricks how you can improve your Spring Boot apps. I'm a Spring guy since already 2007, so that means like I really do Spring and many things related to that. So that's why the topic is really dear to my heart. Yes, so let's dive into the topic basically. So the idea in general is actually like when you're going to write a new application, people will ask you like, how much CPU is your application consuming? How much RAM are you going to need actually for your application? How much storage do you need? What is your technology stack? Obviously, if you're a Spring or Java person, you would choose that stack because you know it best. There will be people out there telling you, write your application in Rust or in Go. It's more efficient, maybe, right? But the JVM is there already for a long time, and they also have like lots of things underneath which makes the thing stable and also like a power horse. So you have to answer all these questions, and it's usually for a developer it's quite difficult actually like to answer these questions, right? Great. So that brings me to the agenda of tonight. So that means actually like we are going to have a look at the Spring Pack Clinic because I use it as a reference. So we define a baseline. And then afterwards, we're doing some JVM optimizations. We do some Spring Boot optimizations. We have a look at some ideas what you can improve in your applications. We talk about different runtimes, and I have some conclusions at the end as well. And besides that, I will show you one example where we basically like put all the things together. So you can see afterwards a huge difference actually like in startup time, in memory consumption, for example, in throughput of the application and so on and so forth. So that's the goal, actually. But before we start, I want to talk shortly about the Pet Clinic. You probably know it already, because it's this application, which is actually a CRUD application, which serves some HTML pages, and you have some paging on it. There are forms as well, and so forth, right? So it's not a very special application, but it's often used as a reference to compare things. Because I think it is also great actually for the talk, because you can actually use the Pet Clinic and you can try it afterwards yourself. And I'm not coming with my own application, which has maybe some special cases in there, right? So the Pet Clinic is actually great. And I just want to give you some other insights, because like in the Pet Clinic community, and you see that on the link, that's a special GitHub organization, there are many implementations of the Pet Clinic. So if you want to be inspired in different technologies, for example, like Angular or Hilla, or you want to do it reactive or microservice-like, you can basically clone those repos and run it. because these are some demo implementations, and you can easily get an idea how you would do it in a certain technology. So that's why I think that's actually a great starting point if you want to use something new in your setup. But I want to tell you, no, I'm not going to use any of those Spring Pack Clinics. I'm using the official Pack Clinic, which is actually like a Spring project, an official one. It's based on Spring Boot, uses Caffeine for caching, has Thymeleaf built in to serve the HTML pages from the server side. It does some Spring Data JPA. I use the version with H2. You can also choose like different profiles, and you could switch like to MySQL or Postgres if you want to. And it uses Spring MVC, which is the base technology for all web applications in the Spring ecosystem. So keep that in mind. My Spring Pack Clinic is based on those technologies. So we are going to use this, and we will benchmark against this one. So when you are going to do the things afterwards, you also have to be aware of, if you go, for example, to start Spring I/O, you will find the Spring Boot application you can generate there by default with the version of Java 17. So that's why I use 17 as a baseline, and we are going to compare with 21 and obviously also with 23. It uses buildpacks to create OCI-compatible containers, like Docker containers, right? So I'm not going to write Docker files. And you see also, like in tests, we use test containers, and there are also some database migration script to set up some test data. On the other hand, what I go to examine is basically like the build time, the startup time, resource usage, container image size, and also the throughput on the application. So we'll see that afterwards in the slides as well. But just a mention on buildpacks. Who of you knows buildpacks? A few of you, that's great. For the others, buildpacks is just a way that you don't need to write Docker files. And Paketo is an implementation of buildpacks. And I like buildpacks quite a lot because it can package your application, it doesn't have to be Java, into a container. Buildpacks are there already for a long time. So in Cloud Foundry or in Heroku, they use buildpacks actually to create containers for the application you're building there, right? That means like the platform used to do that in the past for you using buildpack to create the containers. Now you have the Spring Boot Maven plugin or the Spring Boot Gradle plugin to do that the same in your build pipeline. So if you look at what actually like the buildpacks produces, and I know it's a little bit tiny, but imagine that the part above the Spring Boot banner from Pet Clinic, this is actually like the output you would get from the buildpacks. So buildpacks are great because it lets you write the Docker container in the right way. So that means, for example, you do run with a non-privileged user, for example. You have the memory sizing done correctly because they use something called Java Memory Calculator. And it just generates with the resources applied to your container, it uses this data and generates the X parameters for your JVM startup, for example. It patches the CA certs of your installed Java version during the startup and many other things. And obviously there are things like, for example, if we have an out-of-memory error, the container will just die, so Kubernetes could restart it immediately. So it adds many parameters which are actually quite nice and which should be done by default. And if you go actually to the internet and search on websites for how to build like a Docker container with a Docker file and with a Spring Boot example, you would often see, for example, that they just add the fetch jar. And Spring Boot apps actually run faster when you explode them, when you deploy them exploded, so that means like unzipped, right? And buildpacks do that for me automatically. So there are many reasons why you should actually use buildpacks, because they create the better container for you than if you would do it on your own. So I would say buildpacks are 1,000 times better than your regular Docker file because they are more secure, they're maintained by the community of buildpacks, and also, for example, you will have like some base image from Ubuntu, for example, which will be fixed by the Ubuntu community immediately if something happens. Or, like in other words, Josh Long would say, friends, don't let friends write Docker files, right? So that means like you really should use buildpacks because it's like way better. Great. So let's go to the benchmarks. And in the benchmarks, as I said before, we are going to have a look at the build time. So I measure with Maven actually like the build time. I have a look at the produced artifact, which is in our case the container image. We look at the startup, And in the startup, that means like startup time and memory consumption just right after startup. We will actually do some load tests with OHA, which is a nice command line tool, which can also like visualize while it's loading the tests. But you can also like disable that thing as well. And I mean the UI, and that's what I do. No TUI, basically like just runs everything on the command line. I do like a 30 seconds warm up, a 60 seconds measurement, like full load, what I can get through in the application. And as you can see, I do the measurements basically like with 2 virtual CPUs on the container and 1 GB of RAM. So that's just like my setup for the thing here. Obviously, that might be different in your case. Maybe you have more CPU or maybe you have less CPU. It really depends with the results in the end, right? But more to that later, especially when I talk about virtual threads. Great. So let's go and have a look at the pet clinic without any changes. So basically, I use Java 17. I use the default Java memory calculator, no adjustments, and I just like built the application, which took now with Maven like 65 seconds. We are having an image produced which like 360 megabyte with Java 17. We have a startup time of 5 seconds, basically. We have initial RAM usage of 260 megabyte. We get almost 800 requests per second through. And then you see basically like afterwards, we consumed like 370 megabytes of RAM. And then you see the percentiles for the response times of the requests, basically, right? So the numbers are not that bad, actually. So what are you going to do next? We want to check maybe within your Java version. How would that look like? So that means like these days you would go with Java 21 because that's the next LTS version. And that means just like I'm changing the project, so I run now with Java 21. And I create the container, and you see build time is like kind of like similar. We have an image size which is slightly bigger, but startup time is around the same. And also like the initial RAM is 270 megabyte. We get more throughput on the application actually just by upgrading to Java 21. We have 300 and almost 90 megabytes of RAM used after the throughput. And then you see actually like the response times also get better. So basically like what you can take away from just like this upgrade is always upgrade your JDK because usually it gets better over time. But be aware of, and I think actually like Java 17 is not that bad. Because what I could see in my studies when I like did these many benchmarks in the past, because I'm doing that already since 2 years, just the last number, so the micro version actually like makes a huge difference. So I always do like 17.012, and when 17.013 is out there, I would use the newest version, because usually that means like it's a performance improvement. I can tell you the same basically about Java 21, and about Java 23. And since that is a release which was recently released, there is no patch version, and usually like this version is not so good in performance. So I have the assumption, and prove me wrong, that they fix the things afterwards, right? So they release it, it's going like somewhere, people provide feedback, and then afterwards it gets faster. So I'm really curious about like how this looks like in 1 month or 2. I do not expect like many releases since it's not an LTS version. So you could actually see here, 21 is just on 04, 22 was on 02, and now 23 is basically on 00, right? So usually you get some improvements, and what you can see is from my numbers basically is also like that the response times on 23 got way better in general. But I would even expect some better performance with later versions of 23. Actually, by the way, I didn't tell you like how I do my measurements. I don't have like 100,000 runs to get a proper average number. So usually I run like the test like 7 times, remove the peaks and make an average. So this is like a real world scenario, I think. So that means like if certain numbers are really close to each other, it could be still like an error in measurement actually. So I would expect like 5% error, which is still like almost the same, right? And it's running on a dedicated machine with guaranteed resources, so almost no side effects. So I'm pretty sure the numbers are not fluctuating too much. And that's also what I could see like in the runs as well. So just as a side note, how I do my benchmarks. Now let's have a look at some JVM optimizations. I mean, obviously you can change garbage collector and stuff like that. And I mean, there are garbage collectors which are optimized for throughput, others are low latency garbage collectors. I'm not going into that. I want to show you a few examples how you could actually like tweak your application in certain scenarios just to achieve a goal. So probably the worst thing you can actually do is using no-verify, because I would never use it in production. But that means like when you're loading classes, the verification of the class is not done. So that means startup times. So the thing is actually like everything else should be still the same, right? So it's just like starting faster. I'm using here for the buildpacks the Java tool options to provide another parameter actually to the JVM, and that's why I just have up there in the script basically like this no verify in the Java tool options. But everything else should be actually like really the same, except if you're loading like a lot of new classes, right? So startup time with no verify is better than actually like the Java 17. By the way, when I'm comparing, the one with the clock there or with the watch is actually my reference. I'm always carrying this one with me throughout the whole talk. Great, but I'm sure you saw that before. A thing actually I recognized is the tier.Stop level, which is actually like a thing where you basically like influence the JIT in Java. And when you run from IntelliJ, your Spring Boot app, they will use tier.Stop level 1 because they can improve the startup time. And this is just about the startup time, so it means like using C1 instead of C2. C2 does monitoring and other things and optimizations, whereas C1 is basically static and it's just like optimization for the startup, and then there is no optimization afterwards. So if you do something like serverless functions, this tier.Stop level 1 actually makes sense because you start faster and then you throw the function away, right? So this is just optimizing for startup. And basically, like what you can see here as well is it's starting faster by a second, just with this single parameter. But usually, afterwards, if you have a lot of load, the numbers get worse. So that's actually like what you should expect. And I think that's quite interesting to see, and in certain cases, it makes sense. So for example, also, I think Eclipse uses this as a parameter. When you start Eclipse, they also use this tier.Stop level 1, so that actually like Eclipse starts faster. That's at least like where I saw it before, right, in usage. If you are interested to do more VM optimizations, there is a super cool tool, which is from Chris who codes, and it's basically an overview which parameters are available in every single OpenJDK distribution out there. They might vary, and you can go and check actually like if the parameter applies to your JVM you're using. If it's OpenJ9, if it's, for example, like the Oracle JDK, if it's like Bellsoft Liberica, as Spring Boot uses by default, for example, you can basically check like which parameters are available and which one you could use. So cool tool as a side note. Now let's jump into Spring Boot optimizations. Spring Boot optimizations, there are a few of them, how to like improve your Spring Boot app. And here is the thing actually like that you could say, let's make all Spring Beans lazy. Lazy Spring Beans means they are created when they are used the first time. And obviously that should improve startup, and it does. But on the other hand, afterwards, the response time should be exactly the same. Because if you warm up the application, all the Spring Beans are initialized, and therefore there's exactly the same situation. But lazy Spring Beans actually like might be a thing during development where you say, I want to improve the startup time during development, for example. Obviously, they also have drawbacks. Let's give me like a second, I will get to that. You will see actually like the parameters I provide here is like the -e in the Docker run is basically an environment variable. So I'm a lazy developer, so that's why I don't use screaming snake case, you know, uppercase and underlines. I just write the property name as I would write it into the property files, right, in Spring Boot. So I'm just passing from the outside these parameters, and what I also do besides specifying like lazy Spring Beans, I also make Spring Data JPA lazy. So that means like Hibernate will be also initialized lazy afterwards, right? So that means actually like the first request is probably like the most expensive request we can have. On the other hand, you don't see it in the numbers because I do warm up, right? So it doesn't show up here. You have to be aware of this. By the way, lazy Spring Beans also come with a drawback, basically. So the Spring Beans are created afterwards when your application is running. Usually Spring Beans are created with the main thread. So that means like the first thread who hits your main method, executes your main method, will also create the Spring Beans. But when you do a request and the beans are created then, you might get exceptions because a Spring Bean cannot be created, but by a worker thread of your Tomcat, right? So that means like your application will not crash. So that's definitely a drawback, and you have to make sure this works for you in your case, right? Another idea, which is actually like pinning the configuration location of Spring Boot. Because if you talk about the application YAML file or the application properties and even the profile-specific ones, they're basically picked from different locations. So you could actually say they are from 4 different locations picked up, and Spring Boot has to do that for the YAML files, for the property files, and so on. And when I provide Spring config location, it's basically the thing that it fixes the path, and it's not doing the check for the others. So that means we can save tiny bit of time actually, like during the startup, not doing the checks where we have the files. Now let's get to another topic. I mean, we all know actuators and probably we love them because they're for free, right? And they have great features. But if you don't use them, throw it away. Because you can see just the pack clinic with actuators, it's 448 Spring Beans. Without, it's 272. So that means basically the actuators, they create a lot of Spring Beans during the startup. But the actuator creates also a lot of overhead because it does metrics, tracing, and all the other things, right? So there's a lot of things actually there too. So if you do not need it, if you can afford to not use it actually, don't use it, right? And it's not about the 2 megabytes you save in dependencies, right? So that's the thing there. Okay, cool. The next idea, which the Spring team actually brought up is actually ahead of time processing. And I'm not talking about Graal native images yet. Ahead of time processing basically like does the evaluation of all the Spring Beans before. And basically that means you can get rid of component scanning during the startup in production. So that means actually like the Spring AOT process is baking the Spring Beans into code. It's evaluating configuration, it's evaluating the component scanning and other things, and writes the creation into a single file. In the past, there was something called Spring Context Indexer as a project, and we were writing all the components in one file, and when the file was available, the application context during startup was reading that file, and instead of doing entity scanning, component scanning, and so on. So since that is not supported anymore since Spring Boot 3.2, so that means like a year ago, basically, we have Spring AOT as to save us, which does more or less the same. And that means like Java classes are created, and these classes will be used during startup. So that means actually, and now we get to the very beauty part, we can actually like specify in the Spring Boot Maven plugin the following thing. We specify process AOT. So we tell the Spring Boot Maven plugin to create these classes which generate the Spring Beans with code instead of doing component scanning. And what we do additionally is we provide this build pack environment variable where we say AOT enabled. Because the Spring AOT enabled is a property where we tell the application to use the AOT classes and not doing the component scan. Because of backwards compatibility, it's like this that you really have to enable during runtime the -d spring.aot.enabled equals true. But the build pack, this way, is going to do it for you automatically. So you don't have to care, you just set it up once in the build pipeline, and they will do that from within the container. So what you're going to see is also like with different Java versions actually, is actually that the startup should be faster. Obviously, it takes a little bit longer because there is more classes to be generated. There is like more classes to be compiled. So the build time takes longer. That means bigger image size, obviously. But actually, like the startup time will be faster. No class path scanning, right? So because we just run code. Besides that, it should not change so much also like with the response times, right? Because there should not be too much overhead because it should be exactly the same. So that's actually like a very nice thing. Then actually like there is another idea you will probably see when you run your application from within IntelliJ. So when you run it within IntelliJ, actually, like you have a tab where it says like Spring Beans, health endpoints, like the paths you have on your controllers. And IntelliJ is actually going to read this information from within your Spring Boot app via JMX. And it's displaying you this information in the IDE. Thanks God, actually, like since Spring Boot 2.2, there is no JMX by default enabled. You can do that, but you don't need to, or you shouldn't. The same is actually also for the buildpacks, so it's actually like disabled. But there are possibilities you could do that if needed, right? And that means in the cloud, we can anyway not use JMX to do things. We would use REST endpoints, like with the actuators, for example. So I can tell you, just because of what you have seen so far, I love Spring Boot and I love buildpacks because they make my life a lot easier. And you will see actually like more in a few minutes as well. Okay, so let's talk shortly about application optimizations. And the biggest problem is actually like everyone tells you, use this starter, use that starter, and so on. And basically, they are opinionated. So the Spring Boot team actually like thinks that if you're doing a web application, you're doing a single page application. You do REST endpoints and so on and so forth. But what if you don't need those? If you are not a friend of YAML files, why do you need a Snake YAML parser, for example? If you don't do WebSockets, why do you need the Tomcat dependency for WebSocket as an implementation automatically like in your starter? So the question is like, how can I get rid of the things which I don't need? Because starters are good to start an application, but they're not good to end the application actually, right? Okay, so I came across a very nice tool which is called the depclean Maven plugin. The depclean Maven plugin actually can deal with your bytecode and also does some checks actually on the source code as well. And it can even create a debloated POM file, which means basically like you get all the dependencies on the root level and not having like all the transitive dependencies. So the depclean plugin actually creates me a report which looks like this. I know it's also very small, but you can imagine that there are sections in there where they tell you we have direct dependencies, we have transitive dependencies, we have potential unused dependencies and things like that. Obviously, there is a drawback with that because the depclean plugin does not know anything about Spring Boot. It does not know anything about XML files, like the web XML files. It does not know anything about the starters. It doesn't know anything about the scanning of components and entities and other things. So we are kind of limited there. But I guess you have a good gut feeling which libraries you can remove and which you can't. Right? Because, for example, it would tell me that I should remove Hibernate with Spring Data because we don't have a direct dependency there. Yes, it's clear because they are just in files and the tool is not picking up those. So with a little bit of trial and error, you can actually like shrink your Spring Boot application by like having a look at the plugin. And it's even possible, and I wrote the command down there where you could even say I'm using it as a build breaker. So if you use like direct dependencies which are not used, the build will fail in that case. So you can actually like easily add it to the pipeline. Be aware of, I would not do it because it's like it takes like 12 to 15 seconds to create the report. So that's a bit, you know. I don't want to make my builds slower because of that. But if like to run that from time to time to do some cleanup, why not? Cool. So that means actually like we have this dependency cleanup, we can remove some dependencies, we can rerun basically like the build, and you will see faster build times, less image size, right? So that's basically that thing. Good. There are other things you can optimize. And I just came across some ideas because I don't know your application. I mean, obviously you can improve with caching. You can optimize your database queries. You can basically like make things better to reduce the garbage collection, for example. You can do some other things as well. There are like many ideas up there. I don't know your application, so I cannot show you like what you need to do, but I can show you like how to clean up dependencies. That's a thing I can do for sure, right? Great. So just as an idea, you have there a few ideas what you probably could do. Now let's talk about different runtimes. When we talk about different runtimes, JLink is a very nice feature which is totally underrated. So the thing is actually like with JLink, you build a custom JVM. You can reduce basically like the size of the installed JVM by a bit. With JLink, which is a command line tool, you can specify the modules, and I think the module system in Java is only made for this, that we can shrink the JVM and build like custom JVMs. We can like provide some parameters as well, and then you can run your custom JVM and you can run your application, right? That's the idea. But I don't want to do that in the build process like this I'm showing you here. I want to do it differently. I want to do it like this. So buildpacks just have a parameter, I say, let's reduce the JVM, let's use JLink basically like to shrink the image size. And that's what we do. And as you can see, it works even with Java 23 as well. And you can reduce actually like the image size by a bit. Now the question is actually like, maybe there are other ways to do it. I mean, this tool is just guessing. I think I can actually do it even better than that. So that's why I use JDApps to basically like check which modules are used, so I can explicitly specify the modules, right? And this is like what you see here. So I specify with add modules the modules. I say, for example, I'm going to compress the whole JVM, so the zip is a little bit stronger. I say I don't need header files, I do not need man pages. I remove actually like the debug information as well. So that means like this way, I can shrink down my image size as well, right? And you can see also from the numbers, we are like roughly in the same ballpark still, like compared to the regular JVM for the startup and so on. So I think this is a really cool tool actually like to shrink your containers if you do not need all the functionality. Maybe like one or the other have spotted it already. Java Desktop is still there. If somebody is here who can fix that, please fix it, because I'm running a backend application and I don't want to use Java Desktop. Yeah. But I guess it was like one of the trade-offs they had to do while designing the module system. They need to do some re-implementation of some algorithms and move them into a different module, actually. OK, great. Let's talk about another feature you have probably seen, and this is also like related to Project Leiden. It's called class data sharing. So the idea of class data sharing is actually like that you're going to dump all the classes which are loaded into the JVM, you dump them into a file. And then the next run, basically, you load that file. And afterwards, if there are classes not in that specific file, it will load it from the jars you have anyway in your container. That's a very nice feature to improve actually like the startup time by a lot. So you see that actually like with the parameters, and if I do that with this buildpacks, it's going to save in this application JSA. It saves all the classes which are loaded during startup. Now I can use a trick actually like for a Spring Boot application, which is this Spring context exit on refresh. So that means basically the Spring Boot application just starts up and it stops after the startup. And that means the dump is done after this refresh, so we know actually exactly like which classes were used to doing the startup of the application. Then actually like the files are stored in this application JSA, and the container now contains from the buildpacks an argument which is called shared archive file, which is then provided to the Java startup, and the files or the classes will be loaded from there initially. So the thing is actually here that the buildpacks have just a parameter for that, and the Spring buildpack will do that for you behind the scenes. You don't need to know exactly what is needed to be done here. It will do the exit refresh thingy automatically, so you don't have to deal even with the parameters to add it to the process when you start your application. And as you can see, we are now like on 3.5 seconds startup time compared to like 5.2. So this actually like should also improve over time, since they work on Project Leiden and even improve startup time by a lot, right? So everything else actually like should be like roughly in the same ballpark again, because it's really about classes loading during the startup, and probably also like the first requests to make sure that all classes are available, right? That might take a little bit more time, but as you can see, it's already a huge benefit, and you just add that single line to the Spring Boot Maven plugin. Can you see? I love Spring Boot, I love buildpacks. They make my life so much easier, right? And you don't need to do the same actually like in your multi-stage Docker builds, basically. Good. let's talk about other runtimes beside actually using JLink. You can actually use also OpenJ9. That's just another JVM. So OpenJ9 is very nice if you want to save some memory, because they optimize on memory. The fastest startup, I'm not so sure about that. That was the thing they claimed for Java 8, and they had it on the website for a long time, and now we are basically on Java 21, and that's not so true anymore, right? So, but if you want to save memory, actually OpenJ9 could be a thing. So what you're going to do is here, you specify the build packs yourself. So that means like we are specifying the OpenJ9 build pack, and I'm using the latest so I can also leverage like the newer features. Usually, if you don't provide a tag, and basically build packs are like Docker containers, if you just provide a tag, you can be on a version which is like fixed, right? I just go for the latest, so I always also get like the newer version when they do some releases. You have to specify, besides the OpenJ9 build pack, you have to specify the Java build pack as well, because then you inherit automatically things like the Spring Boot build pack and some other optimizations there. So basically, the Java build pack itself would contain a build pack for Belsoft Liberica. That's the default. But if you want to override Belsoft Liberica with OpenJ9, you have to explicitly add it, and that you are inheriting all the others as well. You're using the Java one here as specified. Right, we are going to switch here the things, and even in my build I tried to switch the build to OpenJ9, so you see also like that's why it takes a bit longer to build, but we definitely see that there is an improvement in memory in general, right? Wow. Let's talk about GraalVM. I'm not talking about GraalVM native images yet, right? GraalVM you can run just like as a regular JVM, and they have a better JIT than Hotspot, actually. And that means just I'm going to replace the Liberica with the GraalVM, and I run my application, my Java application, in the GraalVM. It's also already there with the build pack for Java 23, and basically the update procedure is the same like for OpenJ9. But do you see that, for example, the image size is now way, way bigger? It would be actually good if we could reduce the size, right? But it's like way bigger. And if you even see like GraalVM actually like with the Java 23 version, it's like 910 megabytes is image size. That's huge, right? Besides that, as I said before, there should be better optimizations as well. So the JIT is better. That's great. And I wrote on top, it's like the community edition. So this is like what you would get from Belsoft Liberica NIC, for example, and from other vendors as well. Oracle has another implementation, which is like the GraalVM free edition. That's the Oracle version, and you can use that in your production, but it's better. They have a better JIT in there than the community edition, and you will actually also see that in the numbers, that basically also throughput usually is better. So Oracle actually has a community edition which everyone can build, like OpenJDK, and they have their own one which is actually optimized, and which you even could like, where you even can do some other things. I tell you about that when I talk about native images. So I think even like to switch actually like from the community edition to the Oracle one makes sense. There is no data on 23 because like there was no release till Saturday. Basically, like the build packs got a new release on Saturday, so I had to do all the numbers over the weekend. But at that time, actually, like the 23 version was not available in the build packs yet, but in the community edition, it was already. Okay. So what else can we do? We can talk about different builders. So Belsoft, for example, has a builder which is actually using a different base image for the application to run. They use something called Alpaquita, which is an Alpine Linux. Instead of using Ubuntu underneath, and it's actually Ubuntu Jammy, like the regular one, you can actually switch that you say, I'm going to use an Alpine Linux with my build pack, and I'm using the builder from Belsoft. And you have two versions to choose. You can either choose like a C library implementation with glibc or with Muzzle. So you have to choose if you want to use like the hacky version, which is like bigger, versus like the nicer designed version, which is like from the size like smaller, but slower. So you can actually choose, right? And that's why I have, like now with Java 17, the comparison with Muzzle and glibc. And basically what you can see is like you can reduce the image size by half, right? That's actually crazy. Just changing like the operating system in the container. Be aware of that. For Java 23, it does not work yet. It's just Java 21, which is actually at the moment supported. But that's a matter of time. There is another option if you want to go like with the default one, with the Jammy version, so with Ubuntu actually, you could say, I'm not using the default base image. You could use the tiny version of it. The tiny version is usually used for executables, like for Go, or if you use Graal native images, for example, you would use the tiny. But you can also use the tiny actually to install Java, and it works just like flawlessly. Even the Spring team actually uses the tiny version in their example projects, and also like in the smoke tests they run and so on. So why not actually like just specifying a different builder and go like for the smaller size of the Ubuntu version if you're good with Ubuntu. Good. Now let's talk about Graal native images. And I basically like have both versions in here, Community Edition and also like the Oracle version. And I know actually also Alina was talking before about like you can optimize with some hints or basically like with profiles the native image. So the PGO, like profile guided optimization, only works for the Oracle version and it does not exist in the GraalVM Community Edition. So be aware of that. So that means also like the native images have actually like an advance, and the Community Edition is just like what you would get like from everyone else, right? And what you also would realize is that, for example, throughput would be way better in the Oracle version. But as I said before, you can actually use it for free. You can put it to production. It's fine, actually, right? So from the license terms they have. So for me, it's basically a no-brainer not to use the Community Edition, but actually like switching to the Oracle one. Okay. So and we also saw, because we have now native images, build time is actually like increasing quite a bit. So usually like we have 5 to 8 times more build time. And you have to think of like your process, how you develop your application, right? And not building it too often, like with every commit or so, because it just takes like ages until it got built. Okay. There are other ways then also to optimize that. I didn't do it here. So for me, the important thing was just like, I want to switch actually like to the native images. So I basically like enable with MVN pnative, basically like the generation, and it will happen automatically, right? Okay, so there is another topic which is called CRAC. And that would be also a great advantage because CRAC is about coordinated restore at checkpoint, which is basically dumping the whole memory to disk. So you could restore from your process which was dumped, and you can continue running your application. This is currently supported from Azul and Belsoft as well, and you could do that, but actually like we have some challenges there. Because the challenge, the biggest one I have, is there is no build pack for this. And probably there won't be, because there are even more challenges with the whole approach. So if you would do it manually, you could easily like script it yourself, and in the end, you also need to have like special privileges to run the container to basically do the restore of your snapshot, right? So this is just like how you would do it manually, basically, and that's the idea. Be aware that the whole thing only runs on Linux, because you need Linux, not macOS, not Windows. It won't work. So I think Azul has a version where it can simulate actually like the CRAC one if you are developing things actually like on Windows. But it's not real CRAC, it's just simulated. And yeah, and Spring supports it already since like last November with the Spring Framework 6.1 release. So it's there, right? OpenJ9 has something similar, which is called Creo support. CRAC is actually based on this Creo support as well. So basically, they do the same thing here, right? So that means actually like other vendors might have this implementation, and it's a different JDK you have to download from their website that CRAC can be used. So you see now I cry. It's really sad that there are no build packs there, because that would make my life easy. But be aware, if you like dump the process basically to disk, you might have secrets in there, and you will have other problems probably. So that's why it's also great that there is no build pack out there, and probably there won't be one in the near future. Because like many things need to be solved, as I said, like dumping secrets. You have to run on the same CPU architecture. It needs to be exactly the same operating system. It needs to be exactly the same Java version and so on. So there are lots of challenges. Basically, you would have to do the snapshot in production, right? So I'm not sure if that works for you. Good. For functions, it's perfect, and that's why AWS does that as well, actually, like for some lambdas written in Java. They have support there. Let's talk now about virtual threads. And virtual threads are another thing, because you heard of them already. You can run millions of threads, actually, like in your application, right? It's cheap. And the great thing about that is in Spring Boot, basically, you're just going to change a property to do that. So like the starters and the auto configuration is just using this Spring threads virtual enable true, and it will replace the regular threads with virtual threads. So that means your Tomcat threads are virtual threads if you change this. Keep in mind, Java 17 does not have virtual threads, so that means like that's why the numbers are so bad. But what we see now with the 2-core example, it's like way better, right? So actually, we have an advantage, and you see that also like with the numbers. It's kind of insane, right? But what I want to show you is even better, because if you hear people talking about virtual threads, they're telling you the less CPU they have, the better is for virtual threads. And what you can see here is I did the benchmarks with 4 CPUs, 2, 1, a half CPU, and also a quarter CPU. And basically, you can say, in any case, virtual threads are better. But you see also in the results, like with the quarter CPU below, the response times are slightly better. But everything else does not matter so much. So you could say basically like the sweet spot probably is around 1 CPU, where you get the most gains, which is quite interesting to see in the numbers. I did actually the same in 23, so we can compare it by a bit, right? And we see exactly the same here as well. So this is actually good news, right? You need at least like one CPU to run your application. Then your virtual threads are perfect, actually, and way better than the original result. You see, in this example, you get like 7 times, 8 times more requests through the application, which is actually like crazy, and the response times are even better. Great. So let's sum up the whole thing. We have seen lots of optimizations. I'm just like listing them here again so that we have a good summary. But be aware of, when you do Java applications in general, 4 cores are usually best. So this is kind of like the best startup you could have. The more CPU for your application, in a lot of cases, it doesn't make a huge difference anymore for startup, right? If you go down, it may decrease like linearly, and it might even get worse. So that's the thing, right? So if your application is a bit bigger, give it 4 CPUs. I'm not sure if your infrastructure people will like it, because it might be quite expensive, right? That's the other thing. So it depends also on your use case if you want to give the application so much CPU. On the other hand, every application is different, so requests per second do matter for your application, do benchmarks, right? And you might actually also consider other runtimes, as I have shown before, because the thing is also there are paid versions out there of JVMs, because they have special features. And sometimes it's worth it to pay for something, right? Great. And there are actually other ideas I want to implement, and obviously I'm waiting for CRAC. Tree shaking would be a good idea to try if we can do something, or using an obfuscator. There is more JVM tuning. You could change garbage collectors and things like that, and even Project Leiden out there. So that means like even those things like will probably make it into the presentation in the future. So let's have a look shortly at a few optimizations applied. And you will actually see here that I cleaned up some DB drivers. I removed actuator, I removed Jackson, I removed the snake YAML parser, I removed the WebSocket implementation. I was using either Belsoft Builder or the Builder, the tiny one. I use JLink, I do some JVM parameters, some class data sharing, some Spring AOT, some lazy beans, some fixing of the config location, and even virtual threads. And this is like how it looks like, right? So you can actually like compare it to Java 17, and you see basically like startup gets way better. Memory usage is also on the better side. Throughput is also like way better, and that means like you really can combine those things. And a lot of tiny things, you can actually like combine them to get better results. The same thing actually I do with this tiny builder, and you also see that I added here like the virtual thread examples actually like where I turn it on, so that is visual, and we compare other things in Java 17, obviously not to virtual threads. And it makes really a big difference, right, if you look at the numbers. Okay, so that was it. I will be still around like for the whole week. I don't want to let you wait here and miss the chance for beer and probably fries. If you have some ideas what I could actually also test, and maybe for the next iteration, let me know. Hit me up out there, and let's talk. And if not, you can grab my slides here, and also like the adjustments to my demo project. And if you grab those things, please vote for my talk. Thank you very much.
All systems are nominal. Initialize Genesis sequence.